Hey, everybody. Welcome to the Rambus Design Summit. This presentation will be focused on LPDDR5, which is delivering high bandwidth for a growing range of applications. So if people are familiar with the marketplace of memory, there's a lot of different memory types out there. LPDDR5 is focused on low power. Historically, that's been used in mobile applications, but it's finding increasing use not only in mobile applications, but non-mobile applications due to a combination of low power, high performance, small footprint, and reasonable price. The latest generation of LPDDR is called LPDDR5, and that supports up to 6.4 gigabit per second per pin. So with a 32-bit device, you can get 25.6 megabytes per second of transfer. So that's very interesting for a wide variety of applications. Rambus and two of our partners, OpenFive and Avery Design Systems, have been collaborating to deliver a fully integrated and verified LPDDR5 solution. And in today's presentation, we'll be talking about each of those pieces of the solution. I'm the Senior Director of the Rambus Memory and MIPI Controller Group, and I'll be talking to the controller. Ketan, can you introduce yourself?
Sure. So I'm Ketan Mehta. I'm Senior Director of the Product Marketing for all the connectivity IP at OpenFive. Thank you, Brian, for inviting us.
Excellent. And Ketan will be talking about their LPDDR5 PHY. Chris, can you introduce yourself?
Yes, hi, I'm Chris Browie. I'm VP of Sales and Marketing for Avery Design Systems.
Excellent. And Chris will be talking about their VIP solution. Okay, so with that, let's jump right into it. So we have been Rambus has been providing controllers and PHYs for both memory applications and SerDes-based applications for a long period of time. The memory controller solution we have is focused on being a modular, very configurable solution. It consists at the base of the controller, plus in blue, a variety of add-on pieces. And we deliver that integrated and connected to the target PHY, in this case, the OpenFive LPDDR5 PHY. So this package is delivered fully integrated and verified together as a single package when the customer is orders that. So from a LPDDR5 controller perspective, as you'd expect, we support all of the LPDDR5 speeds up to and including the 6.4 gigabit per second and densities, 32 plus gigabit per channel. This controller is based on our third generation memory controller architecture, which provides very strong bus efficiency across a very wide range of traffic patterns using a whole bunch of optimization techniques, reordering and look-ahead processing, bank management, etc. From a user interface perspective, we support a full range of AXI widths and speeds. Particularly differentiating feature with the LPDDR5, normally the way error correction coding is done is you do use a separate memory in parallel to the main data memory. Because LPDDR5 is not available in by 8 widths, that's not really possible. So what we have developed is a way of doing very efficient inline ECC correction coding where the data and the error correction bits are stored in the same memory, and that's done in an efficient fashion. So that's a particularly differentiating feature for people who are interested in having error correction coding. We also have a very comprehensive memory test support, which performs a full standalone test of the entire LPDDR5 memory subsystem, including the controller, PHY, package, board, and memory device. As I mentioned, it's a highly configurable and modular design, so that enables the gate count to be minimized and us to deliver exactly what the customer needs. As I mentioned also, we have built this on our 3rd generation memory controller architecture. That architecture has been used in more than 140 design wins, and every single one of those designs that is taped out has been first-time silicon successful. And as also mentioned, when it's ordered by a customer, we collaborate with OpenFive to provide a fully integrated and verified controller and PHY solution. The controller itself is DFI compliant, which of course the OpenFive PHY is also. From a deliverable perspective, we deliver the controller with all the various pieces that are needed by the customer. Without the pieces that are not needed, we handle the integration and verification with the OpenFive PHY. And we also provide a full test bench, which includes the Avery LPDDR5 memory model to provide an out-of-the-box demonstration and expert technical support to ensure the customer is supported all the way through the design, verification, tape out, and bring up process. All right. With that, I'm going to turn it over to Ketan to talk about their LPDDR5 PHY. Go ahead, Ketan.
Thank you, Brian, and thanks to Rambus for inviting us for this summit. Once again, my name is Ketan Mehta, represent OpenFive. Just a brief introduction about OpenFive. We are a business unit under Sci-Fi. We developed the full silicon service solution along with quite a bit of connectivity IP that we provide in the memory and the interface side of it. Okay, next slide, please. So in terms of the LPDDR5/4X that we support, these are the value proposition. We entered late to the market, but we learned a lot from the market. We are providing the IP at about 6400 megabit per second today. We have a 216-bit channels, which are less than a 1.5 millimeter square. That's the key value proposition we have. And we have done a channel length measurement up to 1.5 inch because the memories are implemented on the PCB itself. We also have the power numbers, which are 1.5 picojoule per bit. That is quite low in the marketplace, and also about 306, roughly 300 milliwatts for 216-bit channel. So those are some of the key performance metric and power metric that we have. In addition to that, we do have a flexibility in terms of DFI compatibility, lane remapping, the firmware-based training support, and also we've done lots of SIPI simulations on the PCB. We have some of the IBIS model available, as well as we have done a lot of signal noise numbers for our customer, so that we can present that to the customer. So essentially, this is the value proposition. Brian, we can go to the next slide. In terms of the features, as Brian said, we do support DFI compatible PHY. So it essentially connects to the LPDDR controller. Together, we have done already the interop. So that's out of the box experience for the customer. It has most of the features in terms of the PHY that needs to support it. For example, command bus training, the WCK duty cycle training, the read and write data training. We have done ZQ calibration, 2D eye monitoring. So you can pretty much draw the plot for the eye. We've done lane remapping, and also we support the optional training through the firmware and PHY independent training. So essentially, it has pretty much all the features that LPDDR needs to be supported. Earlier, Brian mentioned about the market for the LPDDR. So essentially, it has not only just the mobile, but also the non-mobile application in this today, which is in the IoT, and most importantly in the edge inference market, which are the one driving factors for us for the LPDDR5. Having low power and high speed helps in the edge AI market space. Next slide, please. So here is the PPA for our PHY metric. So as you can see, we support up to 6400 megabit per second. We have different core and IO voltages. And then we do about 1.5 millimeter square, as I said, for 2 16-bit channel together. That allows the flexibility to make it either a 2 16-bit channel or a 32-bit channel or a 64-bit channel connected to the controller. In terms of the power, we have different power states also. So you have a power target, which is about 306 milliwatt, as I said earlier, at a certain read-write condition. But we also support the idle power and the light sleep mode. So that helps with the power utilization for some of those mobile applications. Overall, as a soft PHY, which is the logic that goes on the top of the hard PHY about training and the lane remapping, etc., and the state machines, they consume about 250 to 300 milliwatts of power at typical condition. We do support 11 metal stack, also 13 metal stack, and then we do support both the north-south and the east-west orientation. What that helps is, if your customer is putting an LPDDR on the edge of an ASIC in the north-south direction and the right, as you see the picture on the right side, you can put it in the corner that effectively uses the ASIC area. On the top right, I have a picture showing 2 16-bit channels. So that's our dimension for about 3560 by 425. And you can implement some of the logic underneath those bump map of the physical PHY. Next slide, please. In terms of the deliverables, of course, we provide all the documentation. In addition to that, we do provide some of the early design utility. For example, the left file that you can do the floor planning. We do provide the RTL, encrypted RTL and SDC script, and some of the DFT related deliverables. As a backend kit, of course, we provide the hard PHY, the lib, and the netlist, along with the IBIS model or the SPI simulations. The customer has to get the behavioral model for the memory from the memory vendor, but we do have the behavioral model for the hard PHY. We have a simple verification test bench. In addition to that, as Brian said earlier, we have a combination of the controller and the PHY done as an interop, which already works. So that's a great entry point for the customer. And as the silicon comes up, we have the silicon care report right now in 2 stages. One is the typical condition, and then we provide another one at full PVT. And we also have the evaluation board on request that I'll talk about it in the next slide. So we already have the silicon. We got the silicon earlier this year, and we are going through the characterization of it right now. Of course, this is on N7, and not just the IP, but we have created a full mini SoC, you can say, on a particular evaluation board, where on the left-hand side, you can see that's a PHY plus a controller already built into the chip. And on the right-hand side, we have another our interface IP, interlaken, that connects to an FPGA. So you can pretty much run the traffic through this evaluation board at full speed. So on the left-hand side, we have a controller and the PHY. And then we have this one in the lab right now that we are going through the bring up of it. The picture of the chip you can see in the bottom and the evaluation board as well. That will be available for our customers in the second half of 22 of this year. And we have a lead memory vendor customer which is already using this as a bring up. Okay, next slide, please. So that was my last slide. I would like to invite now Chris. He can talk about the Avery and the design system for LPDDR. Thank you.
Thanks, Keaton. Next slide, Brian, please. So I'm going to spend a couple of minutes talking about Avery's LPDDR5 memory VIP for verification of both memory controller as well as complete SoC designs. As already mentioned, Avery and Rambus are close partners with over 10 years of collaboration on memory and high-speed interface IPs to bring the highest quality and most capable IP and verification solutions to our customers. And in addition to LPDDR5, we do work with Rambus on all the other various memory technologies that Rambus supports in its memory controller or IP product line. Avery is a leading supplier of VIP with over 60 or more protocols, and we support both System Verilog UVM simulation based, as well as FPGA accelerator based verification, as well as virtual platform co-simulation environments, enabling system level verification. So VIP has certainly come a long way in the 20 years since Avery started working on VIPs. Next slide. One clear advantage of using our memory VIP is that with one model, we can support all of the different vendors, including generic JEDEC timing. This improves integration, verification, and debug greatly. And with Rambus, including the Avery VIP and the evaluation packages, engineers can see how the IP core level test bench works first and then apply that to their own actual SoC design project. Our models are developed in native System Verilog UVM, and we support dynamic runtime configuration of the models, as well as support all the key LPDDR5 features, including all the bank architectures, WCK to CK modes, the training and leveling modes, read data strobe modes, dynamic voltage, scaling transition flows, link ECC, in reporting, obviously the data, all the densities and DQ widths, all the speed grades, including LPDDR5 and 5X. The model support programmable read data I margining and skew, and obviously support single and multi-rank topologies. The dynamic timing class allows you to select the vendor timing based on the vendor's data sheets for the various mobile, automotive, or data center versions of their parts. And our models are robust and support all commands, including WCK to CK sync modes and frequency set point operations. Some of the other key VIP features include comprehensive protocol and timing checks, direct memory access to mode registers and the memory array for backdoor load of data or inspection. We support functional and protocol coverage to help verification closure, and performance metrics to verify the memory controller performance. Next slide. But one of the key things is debug, and debug is really crucial. And our memory models provide a memory bus analyzer tracker log to track all the memory operations. You can see the mode register settings post initialization, as well as see all the LPDDR5 command operations. This is a better level of abstraction to work at compared to using waveforms, and can be more effective for hunting down memory subsystem issues. So that's a brief overview of our LPDDR5 memory VIP and how we've been working with Rambus to bring a complete solution for design and verification solutions into the market. So with that, I'd like to pass it back to Brian.
Excellent. Thanks, Chris and Caden. All right, so now we'll do a quick wrap up. One of the things I did want to mention is that people can submit questions, and we'll do our best to address the questions. If we run out of time to address questions, we will follow up with people individually as appropriate. The other thing I did want to mention is that this presentation is available as part on the platform that you're currently attending here. So you can basically download and review the presentation at your leisure. So just to kind of do a quick recap here. The LPDDR5 solution that we're providing is provided as a fully integrated controller and PHY subsystem, and we collaborate very closely with OpenFive to enable that. As you saw from Caden's slides, we have collaborated to put together a demonstration platform, which has enabled us to demonstrate and silicon prove this platform. And as mentioned, we do have customers using that platform. That subsystem supports all the needed, all the key LPDDR5 features from both the controller and PHY perspective. And you know, a critical piece of that is the addition of the Avery memory models. Their memory models provide, you know, very high level of functionality. They can emulate all the various vendor models. They have advanced timing options, which oftentimes the vendor memory models do not support yet. And their memory models are very easy and high performance and easy to use. So they're an important piece of doing a broad-based verification of an SoC design. So we have, you know, taken these components and put together what we feel is a best-in-class controller PHY and VIP solution. All three companies provide expert technical support, and we collaborate to ensure customers have a good out-of-the-box experience. And we do have optional integration and customization services that are available if we don't have exactly what the customer needs. Oftentimes we can provide a little bit of additional support to tune the controller in particular to meet a customer's specific needs. So that's also something that we can be differentiated in. So if you are looking for more information, please submit questions and we'll do our best to answer them. And also in the presentation here, we have the contact information for each one of us. Feel free to reach out to us directly with further questions. And with that, we'll wrap up, answer some questions, and we thank everybody for their attendance. I thank Keaton and Chris for their participation in this presentation, and we wish everybody a good day.
Thank you.